an explanation of how to get through Imagej, kind of a little intro, a little basics, kind of walking through what everything has. Imagej can be downloaded through multiple ways. There's this cool website right here, Imagej, or Fiji. It's the same thing. Fiji just stands for Image. Uh, Imagej is simply Fiji. I don't know, something like that. But anyways, it's pretty straightforward. You can download it through downloads, or you can go through the website and just Google it. Imagej, Fiji. Both of them are. Um, Fiji is just Imagej. There it is. So you can either download each of these and so forth, and it'll pop up in a little screen bar like this. So this is basically what the toolbar is. It's pretty straightforward, something crazy. But what really sticks out is that this website, imagej.net, is actually clutch, because here you can actually go through and learn all the different things for different applications, different techniques, different plugins, so forth like that. So it's very, very clutch when it comes to being able to just actually going through and getting different things out of the way, different images, different types of particle. Now, like that's what we use. So you can actually go through here, learn how to do it, learn how to better import things, learn how to better go through stuff. So it's not too bad. So go ahead and take a look at this website if you need. It makes it very helpful. I was referencing a lot of this when I was deciding what protocols to design for Brad's project and for Yomara's project. So that's what I did. But anyways, I also have a cool handout of what I did for each step on Brad's project. The idea is similar, and I also did it similar to Yomara's. So the idea is still the same. So it's very, very straightforward. This is all the video or the description of what I've done, but this is going to be a video so you can actually see what it looks like. So go ahead and minimize this for now, and I'm going to show you guys what it looks like. So what's cool about Imagej is that you have a lot of tools. You have your square, rectangle. This is what's going to allow you to draw the boxes for the analysis part. As such, boom. Ovals, polygons, freehand sections, pretty cool. Straight tool, angle tool, and so forth. Zoom in and hand points. But here's going to be clutch. This is going to be your money makers. This is what you need the most. So I'm specifically running this through my MacBook, as you can tell. So, but what I've done most of the analysis one was on the desktops, which is a Windows operating system. So it should be basically the same. I can still go through the processes and just show you everything. So yeah, I'm just gonna kind of show you what to do. This is gonna be a quick intro, kind of what the different things I do, and then the scaling. And then from there, I'll make another video to show you how to actually go through the analysis and stuff like that. So for right now, basically, it's just gonna show you. This is an image that I include just scale. So as you can see below, we want to zoom in, and we want to draw a line. Okay, it's gonna be the very first thing before you actually do anything. So you basically draw a line all the way across, boom, right, line. Then you're going to analyze, set scale, and then this is the known distance, so that is what is calculated by this. And the known distance is 99, but I actually know it's 100 micrometers. And then there it is, unit of length, micrometers, and then global. So click global so that it sets it for every single image that gets used in this software. So you want it to be global because if you don't want to just set this scale ratio just for this one image. As I draw in the next one, as the example, we want it to actually be full, and we want it to follow this scale bar. So that makes it pretty straightforward. In the other videos, I showed you how to actually attach this scale bar onto a TIFF image when you actually are on the Keons. So that's pretty straightforward. So yeah, once you're done, press OK and zoom out, and then there you go. That's the only reason why I have a scale image, just to use it for the scale bar. So that makes it pretty simple. But yeah, next I'm gonna grab this. Where is it? It was here a second ago. Here we go. I think this is it. Nope, that's not it. Nope. Oh, there it is. So here's an example, right? We can drag it on. Boom, opens. It's not the prettiest picture out there, but it's kind of the same area. Ooh, this is a very bad image. Okay, so this is a great example of what not to do. So as you can see, it got ripped, but you can still kind of see the area of interest right here. Okay, if you want to zoom in, you can actually scroll around a little bit and actually see what it looks like a little more. So this is a great image because despite it being ripped, you can clearly see the distinguish between cells and background. Right? Some of these are too big, some of these are too awkward, some of these are a little faded in the middle. So some of these are like not actually cells. So this is why we're going to go through and kind of walk through everything. Okay, it's pretty a lot, but it looks very, very good, right? Clear background, a little bit of staining there on the tissues, but for the most part, you can actually see the differentiation. So I guess a little bit of intro is that this is the neural tract, kind of that little circle in the middle of every image. As you can see here, it has it as well. Boom, right there. Right, this is going to be your money maker right here. You want to have everything through there, and this is going to be your reference point to knowing where you're at in the cell. So what's cool here is that you can actually see a little bit of the neural tract, and then you find the NTS, the neural tract solitarius, which is little teeny balls right here. They look like little ovals. I'm actually going to use the freehand just to show you. So it kind of looks like this little thing, right? But then Chris also mentioned to do like a little bit about here. So it kind of looks like this weird peanut looking thing, right? And it's for both sides. So imagine it being like this. All right, you come out a little bit, go down a little bit, and go down. Very ugly, but that's kind of the area of interest that we're looking for. So how do we get that, right? So obviously you could freehand draw it, but the problem is the area is changing. And since for Brad's project, we're looking for count per area, we don't want to have variability within the counts and within the area, because that just makes it for like very inconsistent data. So what we ended up deciding to do is do a square, right? So this new square box was going to be the money maker. So basically, we draw a box. That way it includes all of this, and all of this. So it does include a little bit more than expected, but it still allows you to do grab generally the area of interest. And this is a very arbitrary way of collecting data, so it's not the most precise, but it's faster, much faster than the other method that we were trying to do. So yeah, unbiased stereology is useful, but not practical for our projects. So basically what happens is once we get that done, you can actually establish the sizing of it. So you go to Edit, Selection, and go to Specify. And you can actually select a specific distance and such. So the width was 2100 and the height was 2700. So boom. So normally there's this image is actually turned, so you actually get the opposite. So it's actually, this image is normally rotated to the left, so actually this is facing up, and so this is up, this is down, this is left, this is right. So apologize for that, but either way, it's just more for examples, right? So that's just kind of how you get the box. That's how I was able to analyze the area of interest. We had multiple ways of doing this, trying to see what to do, where to go, how to actually would be the best. So we really decided that this corner, or actually this corner, this area right here, would be the bottom of this area, and then from there on up, we would include it into the area of interest. So it was the way of keeping it consistent and minimizing any variability, because there could be a lot of inconsistencies, because as for this example, there was like a lot of, like, this was obviously cut, like that's a bad image because it's not a perfect circle, like, or perfect shape like this one, right? So this is kind of the idea behind this. So that's how we got the image, that's how we got that's how you import it, that's how you set it. So that's going to be basically the first part. So I'm just going to go ahead and go all the way through and kind of explain a little bit what we do. So obviously you actually don't start with the box. So unfortunately, the first steps, as you can see in the written protocol, if you want to pull them up side by side, is that you're going to start with image, go to type, and go 8-bit. Right. So if you're not able to actually select 8-bit, it's because you probably exported it as a big TIFF. So that's on the Keon's software analysis. So you might want to have to go back and re-export it as a regular TIFF, because it gave you the option of 8, 16, 32, right? So 8-bit will allow us to zoom in without actually losing any focus and blurriness and such. So pretty straightforward. And the next step we're going to do is process. We're going to smooth it out. Kind of gives us a little smoother image. Enhance contrast. Yes, yes. Boom. Done. And then we're going to do subtract background. Boom, 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 boom. This actually isn't normally what it normally looks like, because according to this, I actually use the enhanced local contrast. Um, so I don't know what's actually going on with that. Maybe it's a difference between Mac, but since it doesn't actually have it, I'm just gonna kind of skip it for now since it's subtract background. It was yeah, no, this isn't it. So I don't want to actually mess up anything. So I guess in the other version of it, it might have it for the Windows. So, bummer. Okay, to continue, after that, once you eliminate some background, get some a little more contrast, bring out the images a little bit. So you might not be able to see it right away in the actual like zoomed out view, but if you zoom in, it actually took away a lot of the background, so it gives you a little more distinction. So kind of select an area of interest when you are deciding what threshold to use, which is going to be the next step. So you go to Image, go to Adjust, and go to Threshold. Not Color Threshold, just Threshold. Okay? And then it's going to give you this value. Boom, right? It's going to be very important because from far, it's like, wow, how do you actually use this? So the threshold is actually going to help eliminate a lot of the background. It's going to be very important for deciding which threshold to use. So I end up deciding to do something around, this value stays the same, 255, but this bottom one you can actually adjust, right? So as you can see, it's going to break out more, take away more background, or you can actually go this way and actually not take away as much. So you can auto it, like that's kind of like, oh, that's what the program assumes it's going to be the best, but actually we want to zoom in and find an area, that way we can select, like find a handful of good cells that you want to kind of generally measure this by, because once you start lowering the threshold, you actually notice that you're actually losing, if you keep your eye right here, you're actually going to be losing background right there, which is kind of good because we don't want to count this as a cell, right? Because that's technically not a cell. This is a cell. This is a cell. That's a cell. That's a cell. A little funky, but it's a cell. That's probably a cell. You know, so you want to be able to just eliminate that kind of variability. So I actually kept mine towards like the 50s, 60s. So 58 isn't too bad, as you can see. There's like definitely that's a good one. Has a little bit of messiness, but these little things would be counted. So I kind of just want to go one more, go to 48, and that looks much better, right? It might be a little deformed, not the perfect circle, but it works. And generally, if you can actually see, there's these look like pretty much getting a good census, right? So I would say 48. Hit apply, and then boom, you're back to black and white. So if you zoom out, voila, got all the background. So as you can see, it actually looks pretty good, right? Cell, most likely cell, most likely cell, probably not a cell, most likely cell, most likely. So you just want to keep your eye out because generally you can kind of get a census of it. And once you do that, you're basically set, right? You can close out this window, and it's pretty straightforward, okay? So that's basically it, right? And the next part would be to actually create the box again. So here you go, my box, select it, edit, selection, specify, 2100. Actually, let's do this reverse, 2700 and 2100 because I didn't rotate the image, but it's the same thing, same area. Because I don't know if you know into the video of the data, you can actually see that 27 times 51 is like 5 million something. So this is normally what it looks like, right? So kind of set this around here, around here. Sometimes it's depending on what it looks like. Middle-ish is where I go for. And then bam, there's your area of interest. And then you go to the fun part, which is the analyze, okay? So for this part, we're going to be doing analyze particles. Pretty straightforward. So you're going to click it, and then it's going to give you these variabilities, right? You can change the size, you can change circularity. So I actually have this already preset. So the size we ended up calculating was 10 to the 300. Circularity was 0.25 by 100. So I'm actually going to show outlines. So in a normal, like this is exactly the parameters I use that I decided work best. So if you would run it, click OK. It's going to give you a summary sheet, right? So this is from previous data. So do right? So it's giving me a count of 508, right? Pretty high. No worries, right? But if you actually want to zoom in, you can actually see this is outlines of all the cells that were highlighted, right? So it's saying, oh, this was counted, this was counted, this was counted. So it's pretty high, right? Like if you look in this area, you can be like, wow, those are some cool cells, right? And like you can know from this bottom side that this is closer to the bottom, which was right there, right? So if you zoom out, you can actually see the box, right? Boom, 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 boom. So you can kind of look at it and then kind of see what you're counting as cells and such. So if you zoom around, you can be like, oh, cool, that's a cell. So this is a very arbitrary, so this is not exactly specific, but the most perfect way because it's just batch processing in a sense, where it's just kind of giving a general census and giving me an average or a ratio or just a value that isn't precise but is close enough, right? So the way I got this method was actually by going through and actually changing the analysis. So if you click this window again, analyze particles, and you can play with it, right? So you can go 10 to 200, right? Or let's go 20 just to see how drastic it is, right? Press OK. Boom, right? Look how much it dropped. 500 to 200. It's crazy, right? So you lost 300 cells. Did you though, right? Because you can actually go through and be like, actually that does look like a cell. That does look like a cell. So it's basically just playing around with the features and the settings of the analyze particles section, and just going through and saying, you know what, I need something that looks more circular, right? So when it's closer to 1, it actually looks perfectly like a cell, perfect like a circle, and 0 is like a square or something very far from a circle. So, and the size is just 0 to smallest, right? So 0 is going to be super, super small. 2000 is going to be like a really, really big item, right? So you just keep on playing with it, right? 199. So basically, size made no difference. It's a life lesson. So yeah, basically you go through and you just play with it, right? 10 to 20. So clearly the circularity doesn't have that big of a difference. So let's just say we go 10 to 20,000, right? Boom. Let's see what we get. Oh, shoot, back to 536, right? So we're now including bigger items. And you can actually see that here, right? It's like, whoa, why is it considering that a cell? That's definitely not a cell. So if we were to change the size, we change the size, but let's say we don't change the size now and change the circularity. Now we're probably going to get like 99. Right, now we want perfect circles. Oh, just kidding, on this image. See, that's why you got to click the right one, right? Run that. Ooh, wow, see how crazy that went down? So now we're actually selecting images that look basically perfectly like a circle, right? Don't want to select anything that doesn't look like that weird funky one, which was right here, right? That's definitely not a circle, and that's definitely not a cell. So the circularity helps not just limit the size, but also the shape of it. So some of them might be a little more awkward and more wobbly. That's fine. No cell is perfectly a circle, but just generally, you don't want to exclude those. You don't want to exclude any like these most likely looks like them, but also be able to exclude the very extreme ones. So that's what playing with the system does. So you get to analyze particles and you mess around with it depending on what you need. And sometimes you know, right? And how did I know the size, right? How did you do that? Well, funny story. I actually zoomed in, right? So let's go back to this image. So let's say I went to a black image, right, without any imaging done. It's a little blurrier, but it's fine. Let's say, so what I did was actually go to this toolkit and actually did the line tool and actually started collecting the averages of cells, right? So you zoom in, you say, okay, how big is this, right? Boom, boom, analyze, and then measure. Oh, it's 8. Let's see, what is it? Length 9, right? That's what I'm looking for. Length. Oh, it's 9. Okay, that's like a width, right? Let's look at height. So click this again. Click it down. Ooh, oh, no, no, no. Line tool. Ooh, boom. Let's measure this again. Boom. Let's see what it tells us. Oh, this one's 8, right? So they're length times height, length times width, basically kind of like 70-ish. So that's like a size of like 70, right? So that's kind of how I play with that around it. That would be one of the smaller ones, but I did find some bigger ones. That's it. Where I was like, hey, that looked a little bigger, right? So it just depends on the cell. So you kind of want to get a range because that's probably a cell, but it looks a little ovally, right? You can't discriminate because sometimes cells aren't actually perfect. So that's just kind of going through, and that's how I decided to get the different size ranges, right? Because I found 300 was like way too big, right? So there was a cell bigger than like a width of 15. I'm like, yeah, that's not a cell. So, and that's how I was able to get this range of 10 to 300 and actually go through and play with it. And once you do, you get all this, right? You can copy, you can press OK, run it, select all, and copy. And you can actually paste this into a different spreadsheet, as you can see. So I go into the let's see if this loads. But boom, wonderful, right? So it's based the brain number, right? Number, and then the counts, and then I trash the rest. So if I were to paste it, I would paste all these: total area, average size, area mean. But I don't actually need these, so I just kept these two, and the other two I just calculated because I knew the area of 2100 times 2700 is equal to this, and then I boom copied it all the way down. right? And then the count per area is basically the value of this divided by this gives you that. And that's the value you use, right? And then because I have this label, I know it's IL6, and then 9C, I had to go look it up, and I'm like, okay, that's a control, right? And vice versa. And then there, this is basically what you need to go into the next part. So that essentially explains a little bit of the Imagej protocol that I designed, why I designed it, and how I got it. So yeah, hopefully this kind of clarifies a little bit of how to use Imagej. You can even use the macros and have it run automatically. That takes some practice, but I have the values already done. That way I will just go through, click run, and then hit whatever macros comes out. Boom, 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 and then it does it automatically for me. Because what you can do is macros and record. So you can actually record all the steps you do. So you can go record, right, and you just start clicking. So open next, right, would be an example. Open next, right. If you had all your files in one folder, it would work nicely. But let's just start here, right? Image, 8-bit, boom, run 8-bit. Process smooth, process enhance contrast, boom, records it. Add image, set threshold, and then boom, set it to 48, boom, right, apply, boom, right, done. And then there, that's basically the hardest part. And then, well, I tried to run the macros all the way through, but you can't actually have the program select the box for you and actually set it perfectly. So yeah, like it marks it as a specific location. So it makes it a little hard. But just start from run 8-bit to end of the threshold, and that should be enough to run a macro. And then you create it, and then you run it, and then that way it runs it automatically. So that's a super fast, super cool way of being able to speed up the process and keeping it consistent. Because sometimes when you're not thinking, you're gonna get mindless. You're gonna be listening to Netflix in the background while you do this, and then suddenly you're just gonna get distracted and mess it up. So it's just easier for me to go run a macros than actually individually click, 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 and so forth. So that's something you can actually practice with. It takes some time getting used to, but I haven't done a macros on a MacBook, but ideally it would be the same thing. So yeah, that's basically everything you need to know for this Imagej protocol. It's pretty straightforward. So if you have any questions, let me know and reach out. So yeah, thanks.